Today we're going to explore solving rational equations, and we've done a lot of these in the beginning of the year, very similar to our first example represented below, where we have different denominators all the way across. They all happen to be integer numbers, and the goal is going to be, as it was in the beginning of the year, to try to clear all our fractions. So in order to clear the fractions, we find an LCD of all the terms represented, which in this case is 12. And we multiply every term in the problem by that 12. So when I have 12 divided by 4, that's equivalent to 3. I have the x left over. 12 over 2 gets me a 6. Times 1 is 6. And then I have 12 over 3, which is 4. And that's being multiplied by the 2. So I have 3x plus 6 equals 8. Subtract 6 from both sides. 2 is equal to 3x, divide 3, and x equals 2/3. Not really a problem. Again, we've done that before. So how is this going to get different? Well, we could have a situation where we have a constant term and a binomial, in which case I need to find an LCD for both, which is just 8 and x minus 4. And I know you're thinking, well, why don't you just go ahead and do a cross product since these are proportions? You can certainly do that, but I'm just introducing this in a different way this time. Distribute through. We end up with x plus 4 is reducing, so I'm left with 6 times 8. In this multiplication, the 8 reduces, and I'm left with 3 and x minus 4. And you'll notice that's the same as what I'd have if I took a cross product. So this is 48. Is equal to 3x minus 12. Add 12 to both sides. You get a total of 60 is equal to 3x. Divide, and 20 is equal to x.
Okay, so now we've got variables all across. We need to look for our LCD, remembering that we have a 1 under this 3. So if I take a look at x squared, and 1, my LCD is x squared. Multiply each term by x squared to clear the fraction. So I have 3x squared plus x is equal to 10. Set aside equal to 0. X squared plus x minus 10 equals 0. We're going to have to factor this. Now again, my choice, since 3 has only one set of factors, is to do a guess and check. You can do the x method if you wish. So I have 3x and x. I have either 1 and 10 or 2 and 5 to use to get a 1 as my middle term. So I'm going to try the 5 and the 2, put my 2 here and my 5 here. Notice what happens. I need a positive x when I add. So if I put a positive 2, 3 times 2 is 6, and negative 5 times 1 is 5. That will give me my factoring. Again, set each equal to 0 by the zero product principle. And add 5, giving me 3x is equal to 5. Divide by 3. So x equals 5/3. Subtract 2 to both sides and get x equals 2.
Here's another example. Notice I have a constant term and a binomial. I'll need both of those in my LCD, so I'm going to multiply by 3 times the quantity of x minus 2 to each term. When I multiply this first quantity, the x minus 2 is reduced, leaving me with 3x. Second quantity, the 3 is reduced, leaving me with the original 2 in the numerator and this x minus 2. And in this last term, the x minus 2 is once again reduced. So I have a 2 times a 3, or 6. Notice 3x plus 2x minus 4 equals 6. no x squared terms, which means I can just go ahead and solve. Add 4 to both sides. 10 equals 5x, and x equals 2. This term, notice 3 different denominators. I can multiply by each of those denominators all the way through, but as we know, we always look to factor our denominator first. So I pull a GCF of 3 out of this term. I know this term multiplies to x minus 2 times x minus 1. And now I need a LCD. So in this case, I need the 3. I need the x minus 1. I need an x minus 2. So I'm going to take and again multiply each term by the LCD of 3, x minus 1, and x minus 2. And distribute that to all 3 terms. In this first multiplication, the x minus 1 and the x minus 2 reduce out, leaving me with a 3 times a 5. The second term, only the x minus 2 reduces, leaving me with this 1 times whatever's left here. So that's 3 and an x minus 1. And then in our last term, we notice the 3 reduces, the x minus 1 reduces, so I'm just left with x minus 2. We've got 15, negative 3x plus 3, and an x minus 2. I'll add 3x to both sides and add 2 to both sides. This gives me a 15 plus 3 plus 2. This gives me a 4x, so 4x equals 20 and x equals 5. So here we have a situation where I have a denominator of 1. I need to factor once again, GCF of 2, so that's x minus 3, GCF of 4, and again x minus 3. LCD in this case, I have 2 and a 4, so I need the 4, and then the x minus 3. Multiply both terms by the 4 and the x minus 3. So again, the 4 and the 2 reduce to a 2. X minus 3 goes, and I'm left with the 3. Subtract by. 4 reduces, the x minus 3 reduces. That's x plus 1 remaining. And the 1 reduces with nothing, so I have 4 times 4 multiplied by x minus 3. Going to need that invisible 1. And this ends up being 16. And I'll have to distribute that through. So I have a total of 6 minus x minus 1 equals 16x minus 48. Again, let's start grouping terms. Add x to both sides and 48 to both sides. End up with 17x on this side. That's 54 minus 1 is 53. So x is 53 over 17. In this problem, we have quite a bit of factoring to do. We've got x plus 4 and x plus 1, x plus 1 and x minus 1. Looks like x plus 4 and x minus 1, which means I need to find the LCD. I need an x plus 4. I'm going to need an x plus 1. And it looks like I'm going to need an x minus 1. I'll multiply both my sides of the equation by that LCD of x plus 4, x plus 1, and x minus 1. Notice the x plus 4 and the x plus 1 reduce, leaving me with an x minus 1. I have the 3, but the x plus 1 and the x minus 1 reduces, so I'm left with a multiple of x plus 4 equals that negative 1 gets multiplied by x plus 4 and the x minus 1 reduced, so that's an x plus 1. I have x minus 1 plus 3x plus 12 equals negative x minus 1. Add x to both sides gives me a total of 5x plus 11 is equal to negative 1. Subtract 11 to both sides. 5x equals negative 12, and x equals negative 12 over 5. That's all we've got. I want to remind you once again, whenever possible, factor your denominators whenever you have addition and subtraction of fractions. So write your lesson summary out and answer the questions below, and we'll chat more tomorrow.